Hello and thanks for joining School of the American Rifle. Today we have 3 barrel physicals. These are Brownells Retro Series M16A1 profile barrels. I can't tell you who makes these for Brownells, but they're 20-inch barrels, M16A1 profile. They're listed as being chambered in 5.56. They are 1 in 12 twists with a chrome line bore. So we're going to gauge these out. These are going to be assembled onto the surplus M16A1 upper receivers. These are actually 2 of them are my brother's and 1's mine. The example that is ours is actually going to be part of the shop. We have a low receiver that we built on the parts kit. You can see we distressed the lower a little bit. I'm going to have a separate video on how we do that, so don't worry about that. But this example will be the shop's example. We're going to mock these up. Set this aside. We're going to mock these up into the upper receivers that the barrels are going to be married to. Make sure that we have proper front sight base alignment. We're going to check with gauges to make sure that the barrel's okay. First thing though, we're going to have to clean these things out because we just pulled them out of the packaging. So let me go ahead and stab a patch on each one of these and force it through so we can get some proper gauging. You see it's a little dirty. Still got to clean the chamber a little bit. I'll run a swab in there and get those cleaned out as well. And this is typical. A good barrel should have some oil or grease in it to work as a preservative, so the barrel doesn't have any corrosion that sets in when it's sitting in its packaging or it's sitting in a storage facility or even when it's being transported. We got the bores punched out. They're clean enough for gauging. Go ahead and get a swab and we'll get these chambers cleared a little bit. Make sure that we don't have anything in the throat area and the neck area. Not too dirty. Discard those. All right, let's go ahead and do our gauging first and see what we get. So we'll go to the front and we'll work all the way back. Let's do our muzzle erosion check. So we go to the first line, which is .2195 on this barrel. Let's go to the next one. Again, same thing, 2195. And then we'll go to the last one. This one's a little bit further in. This is, the previous 2 were 219. This one's 2195. So 2195, 219, 21. Oh, this one went a little further, but this one is 220. So there's about a .0005 difference between these 3 barrels. Not huge, but they all pass. Let's do our barrel straightness gauge. This one we're going to go straight up and down, so we'll have to back up a little bit. We want this to pass through without any interruption. That one passes. We're checking to make sure that the barrel is straight. Sometimes you will fail this test if you have a burr in the gas port or if you have a really dirty barrel. And that passed as well. So they all passed muzzle erosion and barrel straightness. Let's check our threads. Now, I don't think these are going to be suppressed because these are retro builds. They're going to have an old M16A1 birdcage on them with a crush washer. But for the heck of it, let's go ahead and check it with our run-out gauge or concentricity gauge. Screw these on by hand. And let's get our alignment rod. Going this way. And that one passes. This gauge is looking for .004 or better of run out. If the gauge won't pass into the bore, that means that you have at least .005 or worse. Actually, it looks for 003, 004 or worse. So this one passes too. That means that if the rod goes in, it has less than 0.003 of run out. That's usually something you want to look at if you're going to suppress a gun. If you're just going to put a flash hider on it, not that important. All right, all three pass. That's pretty rare, actually. In my classes, I would say about 20 to 30% will fail this gauge. This is what I refer to as quick and dirty gauge. The actual proper way to test this will be to mock these up in a 4-jaw on a lathe, put run out indicators on them, and check it that way. But that takes a good bit of time. This one's really fast. So we have no serious erosion at the front. We have a straight barrel, and we have good threads on all of these. Now let's go ahead and check throat erosion. I doubt we're going to have a problem with that, but let's check it. When you're using this gauge, you can use it when the upper's attached or when the barrel's stripped. If the upper's attached, here's what you'll do. You'll put it in through the ejection port, and then what you're going to use is the front leading edge of the ejection port, and you're going to count how many lines you see. So I can count one. It's hard for me to do the camera and count this. Well, my wife doing the camera. 1, 2, 3, 4, 5, 6, 7, 8. I can count 8 lines. So we have 11 total on here, which is from 0 to 10. So that means we have a 2 for erosion on this one. Let's check it with it off there. We're like a 1.5. See what we can get. We got 1 line, so we're at the 1 now. We're at about 1.5. So the middle one gets 1.5. Let's see what this one gets. This one gets about 1.5 too. Every barrel is going to be a little different when you're using this gauge. This just gives you a starting point. They're all about 1.5 for this particular gauge. So it lets you know after you've shot a couple hundred rounds through the gun, okay, I started at a 1.5. You fire, let's say 500 rounds through there, and in today's dollars, that's about $50,000. I'm kidding. But if you're at, line number 5 after 500 rounds, you have a problem. Your throat should not be eroding that rapidly. All right, now let's check it with a Michigan's throat gauge. This is only checking the throat. The way this works is we're going to go straight up and down with this, sort of like we did with the barrel straightness gauge. We're going to put this into the chamber, and it's only measuring on this surface right here. We're going to give it a little tap like you're trying to get someone's attention, and we're going to see if we can pick the barrel up. And we can't, so the throat passes. All right, we're going to move to the next one. Passes. These are all good signs so far. This one's got a little bit of a tight throat. You see how it picked up? So this one has a slightly short throat. Now, does that make the barrel dangerous? No. What it means is this barrel is probably not true 5.56 when it comes to the chamber. So let's do a follow-up check. Now that we're dealing with the throats and we're checking for erosion, see that's pretty tight in there. What we do next is we follow up with a chamber function gauge. This is a 5.56 chamber function gauge. This looks for the inside of the chamber as far as dimensions goes for the neck, the body, and also the throat. So this particular gauge, we're going to put it in here, let it fall, put a little bit of pressure on it, and we should be able to pull it straight out, and we did. So this gauge here that we just used, this thing is not very forgiving. So if I ever have one that sticks with this, what I do is I follow up with this gauge here, and this also checks for the throat, but also other areas of the chamber. That's very important. Some people just check headspace and we're like, okay, the chamber is good. Headspace is only from the angle or the shoulder for the 5.56 cartridge in this case to the bolt face. It doesn't check for the overall dimensions of the chamber as far as this area here or the area in here on the body. None of those areas. So this is just another follow-up check for a chamber. If you don't have a gauge like this, you can use something like an unchambered live factory round. You would stick it in here, you'd seat it with your finger, and then you turn the barrel upside down and see if it shakes out. And that's a good indicator that usually it's okay. Factory ammo does vary from batch to batch, so you can't use that as a 100% check though. But that does pass. So the chamber on here is good. Let's go to the next one. Chamber's good. And one more. Oh, this one sticks. We have a problem on this one. See? So somewhere on this chamber, we have an issue with something sticking. So what we're going to do is we're going to paint the gauge and see where we have a problem. It was this barrel right here. Put a mark on it so we don't lose it. And normally I would use layout fluid, but let's use some poor man's layout fluid, which is a magic marker. And we're going to see where we get contact in this chamber. Maybe it'll be a problem, maybe it won't. I don't think it's the throat on this example. It's probably something in the neck or the body. And if I was using layout fluid, this would go much faster because it's on an applicator brush. It's called Dykem. And then I can just clean this off with some alcohol when I'm all done. Make sure it's dry. Let's put this in here and see where we get it to stick. Right there. So what we have is a chamber that's slightly undersized, right about, I'd say, 1/4 of the way down from the neck back to the base. So this chamber actually gets constricted at one spot. This can cause extraction problems. Now I do have a flex hone that's designed to polish chambers out with this situation. So what I can do after our video is over is I can go in here with a flex hone and just see if I can get any high spots. It could be something rough with a chrome. We're going to look in here with the borescope as well to see if we can identify what's going on. But I did mark this barrel, so we'll go back to it with the borescope and see if we can detect anything optically with the borescope that will set that apart from the rest. All right, let's go ahead and check Headspace. So we have one barrel so far with a possible problem. All right, let's go ahead and mate these up with the bolt carrier that they're going to use. So let's skip the 223 go and let's go right to the 556. Put this in here, hold our bolt, and it passes the go gauge. We actually have a little bit of slop there, and I didn't expect that we would fail our go. This is the one that I worry about with an older bolt because it could have excessive wear on this bolt. And it will not close on the gauge. So we're safe. We closed on the go, it will not close on the field. Let's go to the next barrel. I'll just put the field in there. Won't close on the field. Let me dump that and put the go in there. Make sure that we don't have short headspace. This is the 14646 556 go. And it closes. So we're good there. Let's go to the last barrel. 14646. Bolt carrier. Closes on that one, which is good. Now let's try our field. We don't want this to close. We're good. So these old bolt carriers still have plenty of life left in them. Alright, so we passed headspace, we passed straightness, erosion on both ends, and we passed the concentric check for the threads. We did have an issue with this one particular barrel in the chamber. It could lead to extraction problems. Now let's go ahead and check for front sight base alignment. Now what I have here is a pretty neat gauge. This is made by Black Rifle Disease Engineering. They sell 3 of these rods. It comes in a kit. This is the rifle length, and they have one in a mid-length, and they have one on a carbine length. Just different length rods. And the purpose is you take it, either you have a detachable carry handle or one that's built in like this one. You lay this rod in here, and it has a nice tight fit, and then you have this other punch that has a point on it. You slide this in, and when your barrel assembly's in there, this should point to where your front sight post is to tell you if you're straight or not. So what we're going to do is we're going to mock these up in every upper we're going to use them in, and we're going to see how they line up. This is a very common problem with a lot of companies. Let me pull these gauges out of the way so we don't drop anything on them. This is a pretty common problem when you have ARs with a front sight base arrangement. The front sight bases can have some cant or clocking in them. Alright, so go ahead and we're not going to worry about timing the barrel nut, and I'm not going to put a bunch of torque on here. What we're going to do is we're just going to put these in the Midwest URR, and we're going to give it a good snug grab with the armorer's wrench. Make sure that they are somewhat tight. And then we're going to check with our alignment rod. And since we shoot our videos raw footage, normally, you know, if you were doing a bunch of fancy editing, you would be doing like double speed right now. We don't do that stuff. The only thing that I'm building on the two for my brothers is the upper receivers. They're actually going to assemble the lowers themselves. They're already distressed. That's what they're building, sort of a distressed assembly. Alright, so let's put this on here. Give it a good snug. I'll probably put about 30 foot-pounds on there. Now, let's check it with the alignment rod. So we're going to lay this in here, like so. And then we're going to pull this rod out, and we're going to try to come down to the front and see where we're at. And this one actually looks pretty good. It's a little bit off. If you see, the front sight base is actually this way a little bit. So if we were to put force on it, this is what we want to see. But this is where we're at. So in this situation here, we probably have enough windage in our rear sight to correct for the front sight post being off like this. This is actually pretty common. You get factory guns with front sight bases, and if you use something like this, a lot of people just use the eyeball check, but if you use a gauge like this, it'll tell you whether or not you're dead on or not. So I'd say we're a couple degrees off on this one, so not too bad. So let's pull that one off, set it aside. Let's come up to the next one. Nice and snug. Again, about 30 foot-pounds. Let's get this locked in there, and let's see where we're at on this one. This one's bad. This one's off a good bit. This one we would probably run out of windage in the rear sight trying to correct this one. So what I'm going to do is I'm going to step off camera to get some oversized taper pins and show you how I would correct this. So the way that I would correct this, of course I could return this to Brownells, but I'm not. These barrels are extremely hard to get a hold of. I think I may have ordered the last three that they had. They had them up for sale for just a couple hours and they were all gone. The retro stuff's really hard to find right now because everybody's building non-retro stuff. But what we would do is we would drive these taper pins out, and then what I would do is after I get the front sight base lined back up, I would then ream the taper pin holes. They're actually cut at a taper like so. So when you realign this front sight base, the taper holes in there misalign. So we have to open them up so they realign all together. What I do is I use oversized taper pins. So what I'll do is I'll get this lined up, oversize these holes, drive these in, and they'll be sticking out a little bit on both sides. I'll cut them to length, round the tips, refinish them, and it's a repair job. It's a little bit involved. I may do a separate video on how to do that. But this one is off enough where this is a concern for me. Now, one thing people will be like, well, what if that gauge is out? So what you want to do to prove out your gauge is just rotate it. Do you see the gauge really moving a whole lot? Nope. We got a little bit of wobble there, but it's still pretty much in the same position. So let's rotate the whole thing and see if we get it where it moves a bunch. It's not moving much, is it? Nope. So the gauge is true. So let's get this off and let's do our last barrel assembly. Again, about 30 foot-pounds. Let's get this in here. And this one's even worse than the other one. Oh my gosh. So this one definitely isn't going to hit paper. Let's go ahead and give it a rotation. Still way out. This one's out far enough that this one might actually be a risk of trying to realign with oversized taper pins, because if I move this enough, it may block off a portion of the gas port. You able to get it to focus? So this one's off a good bit. So this one right here, I would not try to fix. This one is probably going to be fodder to get returned. Brownells has a good return policy, so I don't have any doubts that they'll take care of this. But this one's out. Now sometimes you'll have enough play inside of your index pin notch that when you tighten things down, the front sight base will walk when you tighten the castle nut. But this is the beauty of the URR. It keeps everything aligned within the upper receiver. So if you were to allow this to tighten a little bit more for the front sight base to go this way, what can happen is you can then have a bolt to barrel extension alignment problem. When the bolt tries to come home, it can hit the barrel extension teeth improperly and cause resistance and cycling issues. So those are our 3 examples. Pretty bad, not so bad, and okay. Alright, so now what we're going to do is check these out with the bore scope. So let's find the barrel that had the chamber problems. Here's the magic marker line that I put on there. Let's look at that one first. Alright, we got it mocked up. I'm going to come in from the back with the bore scope. We're going to look at this portion of the barrel, then I'll flip it around and we'll look at the other end. Let me get the laptop fired up. Okay. Bore scope is on. And in we go. Get the focus adjusted. Alright, right about here is our barrel extension. You can see the lugs there. We've got a good bit of glare. Oh, it's our camera. Boom. Alright, so let's go back out. This is, you can see, look, there's the blue mark transfer. So this is where the chamber was grabbing that magic marker. Let's see if we can see any obvious defects. Change our focus a little bit. This is right at the mouth of the chamber. We have different focal planes here, that's why I have to keep adjusting the scope. Let's go forward a little bit. I don't really see anything distinctive. There's a little bit of a defect there. Let's go forward a little bit. The chamber looks fantastic. So I'm thinking at the very opening right here where we have this transfer, we have a slightly undersized chamber there. The best way to prove this out is to actually do live fire. We can actually see some cross hatching right there. So I may just need a little bit of a cleaning. Let's look at the throat. Chamber looks pretty rough there. neck area. There's the shoulder, there's the neck, there's your throat. We can see some copper fouling where they did some testing on it. Finish looks pretty good in there. This is a chrome line barrel. Let's go down. This is the one that has the worst alignment out of all of them. So let's go down and see if we can find the gas port and see if we have any serious misalignment. Maybe we couldn't reach it. Barrel looks good though. I'm going to flip it around. We're going to come in from the front. I want to find the gas port. And in we go. There's our gas port. We're not off enough to cause any misalignment at this point, so now let's go. Let's look at the crown real quick. Crown looks good, so does the front of the barrel. You can usually tell how heavily a barrel was tested by the amount of erosion at the gas port. Go back to it real quick. You can see almost no erosion there. So just a quick test fire round, that's all. Alright, so the barrel looks good. We may have identified the area in the chamber that's a problem. We'll put that near the back. That's our problem child. Let's check this one. Come in from the front. Let's look at the crown. Crown looks great. Barrel looks great. Try to find that gas port. There we go. Let's look up into it. We have good alignment. Can't complain about that. Barrel looks good. Let's check the other side of this barrel. Let's look in the chamber end. That was pretty rough right there. That's the shoulder area right there. That's the neck area. This is our throat. Let's go back and look at that chamber again. Chamber looks better on this one, but this one also didn't let any of the gauges stick. There's our copper fouling from the testing. The barrel looks good. Last one. Going from the back. This chamber looks good as well. I know the camera's jumping around a little bit. Got some more rough spots there in the neck area on this barrel. I'm sorry, that's the shoulder. This is the neck area. That's the shoulder. There's our throat. Got some copper fouling in there. The chrome looks good on this one. Let's go back and look at that throat again in that chamber. This is the chamber area. Chamber looks good on this one. The only one that had a really rough chamber itself was the one that stuck on the function gauge. But both of the other barrels that passed had very rough areas right here. This is the taper or the shoulder. This should not affect function in any way because the casing really doesn't grab much on this. It's mainly on the body and the neck area. Let's flip this around and take a look at the gas port area and the crown. Alright, so we got our crown. Crown looks nice on this. Something happened with our laptop. Oh, it went into a timeout. Crown looks good. Rifling from the front end looks good. Let's find our gas port. You can see some cleaning patch there. It looks sort of gross, but that happens sometimes. When the gas port's drilled, sometimes you get a little bit of burrs around the edge. Let's get that focused a little bit. We'll look up in that gas port, and we are lined up. So, all three barrels did well, with exception to the one that had the chamber issue and the alignment issue. So I'm going to contact Brownells about the one with the really bad front sight base alignment, see what they will do for us. And these other two are going to be part of my brother's builds. I'm going to be the last one to get this gun set up. So overall, I'm not too displeased with these. I expected there to be some misalignment, and that's one of the reasons I like to showcase things on the channel like this, because some people will do an eyeball check and then they get all bent out of shape if there's any slight misalignment. It's very rare unless you're having an armor or a gunsmith that works on ARs day in and day out that gets this perfectly lined up. Most of them will just eyeball it, or they'll use a fixture which they believe is true enough, but there's always a little bit of slop in the parts when the recipes mix together. Let me get this light turned on. There we go. But we have 3 Brownells barrels. Not too bad. I had some fun doing this video. A little disappointing on the one barrel, so only 2 out of 3 are going to get built. But I hope you found this video educational. Thanks for watching.